Hello friends, today let's solve word letter 2 problem. We are given two words, begin word and end word, and the dictionary's word list. Find all shortest transformation sequences from begin word to end word, such that only one letter can be changed at a time. Each transformed word must exist in the word list. Note that begin word is not a transformed word. Let's see this example. We are given the begin word, which is heat, and the end word is cock. And these 6 words are the word list. We need to do some transformation so we can find a way from the heat to cock. So we need to find some sequences. Actually, it's like a generation. You will think about backtracking. Yes, we need backtracking to find a valid way. But how to, build the graph? It's just things like words. We need the abstraction to change it to a graph problem. Let's just do something by extinction. We know the begin word is heat, and then we can change some character, actually one character, to go to another word in the word list. We can change I to O, so we can go to hot. And then we are at hot. We need to change to other word. We can change to dot, change the H to D. And we can also go to lot. We change the H to L. But we do not write heat again, although we can change O to I and go to heat. But this is just an invalid transformation. It will waste many times. It will never be the shortest transformation times. The same idea, when we are at dot, we will not change back to hot because we already use this transformation. So that means once we use a word, we delete it from the word list. We will never use it again. And so on and so forth, we can change to other word. And you see, this is just like the diagram. We are at heat and we change one character. We can only go to hot. But when we are at hot, we can go to 2 different words, dot and lot. And these 2 words are in the same level because we only change one character from hot. And then we go from dot to dog, go from lot to log. This is another level. And finally, we can go to cock. So you will see that we change one character. It's just a cost 1. It's unweighted. Every time we change one character, it's just a cost 1. And another thing is, we can change from hot to heat. We can also change from heat to hot. This is unidirectional. This relation are 2-way. So this is the unweighted unidirectional graph. You will think about breadth search to find a shortest path from a source to target in this graph. Yes, we need to use BFS to find the shortest path. So what do we exactly do in this problem? This is each level, right? And at each level, we can change every character in this word and go try to find whether we can change to another existing word in the dictionary. So actually, we can call it star set for the current level. Although at first it's just one word, but afterwards they may have 2 words in the same level. So that call it star set for each word in the current level, star set. And for every chart in the word, we change from A to Z. We see whether this new word exists in the word list. If it exists, we can build a relation, like from heat to hot. we use a map heat to hot. And once this new word equals to the end word, we finish, right? This must be the shortest path because we go from the target to source. And once we find the end word, we know it should be the shortest path. Do you see the problem about this algorithm? Actually, you see, as we go far, this star set will be larger and larger. So the transformation we need to make is more and more. Can we do better? Yes, we can do some optimization. We can call the end word. Initially, it's just one word, end word. We can call it end set. Once the star set has a larger size than the end set, we can switch these two sets. What does that mean? If we are the star set now is dot and lot, but the end set is cog, we need to change every word and every character in the star set. But actually we can switch these two sets. That means we just change the word in the end set, which is a cog, and every character in this set. Because this transformation is two-way, we can go from dot to dog and to cog. We can also go from cog to dog to dot. But if we just change this cog, it's much less transformation. So we switch these two sets. But if we switch these two sets, the relation is also reversed. What does that mean? If we just keep the traditional breadth-first search, every relation should be dot maps to dog and dog maps to cog. But if we switch these two sets, we can go from cog to dog, but this is reversed, so we need to record the dog maps cog other than cog maps dog. So you need to know that. So once we switch this star set and end set, we also need to reverse this relation. Let's see this example. This is the star set at first is heat and end set is cog. And we change this heat to hot. It's still one word in the star set. So we keep going. And then we change hot to get dot and lot. Now the star set is larger than the end set, so we switch these two sets. So currently the star set is cog and end set is dot and log. And we can change this cog to get dog and log. Previously, we mapped the heat to hot and hot mapped to dot and lot. But currently it's reversed, so we do not write cog map to dog. We write dog map to cog and log map to cog. And finally, this is also star set and this end set, but the relation is still reversed. So we will write dot to dog and lot to log. So this is the graph we built. So the final step will just be do a traditional backtracking to get the result. We go from heat to hot, then hot to dot and dot to dog and dog to cog. And then we unchoose dog, we unchoose dot, we choose lot and lot go to log, log go to cog. So another way. So the final part is just a typical backtracking problem. Okay. So now let's write code. First, I will write the unoptimized solution. We just use the end word. We just start from first to the end. And secondly, I will optimize the solution. We will add these two sets. So now let's write the code. We first need the result list. Result, new array list, and we need to change this word list to set. The reason is that we can quickly look up whether this word exists in a dictionary, and we will pass this, word list. Okay, we will first do a quick check. If the dict doesn't contain this end word, we will never find a valid path. So we will just return the empty list. Then we will use a graph that will be string, and the value could be a list string or a set, as you like. Map, new, hash map. Okay, then we'll do a breadth search. Okay, let's write the breadth search void BFS. We will use the star set because as we go further, in the same level we may have more words, so we just name the start set, new hash set. We will add the start set, start set, add the begin word. Okay, so the first parameter will be the set string. Parameter, start set, and the string and the word. String and the word. We also need to pass the map, right? String, list, string. Okay. So if once the start set size equal to 0, we just return. Otherwise, we also needed to pass this dictionary. So set string dict. Okay. We need a temporary set because we need the words to the next level. So we call it temporary hash set. Okay. We need do not forget to remove all the words in the current star set. We also need to check whether it's finished. So finish at first is false. Then for every word in the star set, actually the current level star set, we changed it to the char array. And for every char, cs.length I++, we save the old char will be CSI. And we try to change to other words. So C start from A, and C less or equal than 0, Z, C++. We can get the new word will be new string. But do not forget change. So CS, I will change to Z, right? Change to Z. Okay. So if the dict contains the current word, that means we can do something. If the current word equals to the end word, we finish, right? So finish will equal to true. Otherwise, we need to add the word to the transform the word to the temporary set. So add word. Okay. And if map get the s equal to none, we will put s new array list, right? Current word, and we will add the map get s add word. Let's transform the word. Okay. So for this for loop, we need to this for loop will reset CSI to the old char. Okay. Okay. Yeah. After this for loop, we will see if finish not equal to true. We need to do another BFS that will be temporary. Temporary is current star set, and the end word and map, and this will be dict. Okay, do not forget to remove all. Yeah, remove all. Sure. So we fill these parameters. There will be start set, and the end word. There will be map. There will be dict. Okay, another thing is to do the depth first search to generate a result. There will be list. Why? Because we need to add the begin word to the list. So list will add this begin word. Then we do depth first search, pass the result list, and the begin word and the end word, final return result. Okay, now let's write this depth first search. We need this list. Oh, list. Sorry. List string result. This will be the string list. Also, there will be current word. There will be the end word. So what is the best case? If the current word equals to the end word, we just add the current list to the result list. But we cannot just add the list, you know that, because it's a reference. So if we change the list, we will also change the result. Okay? Yeah, we also need to pass the map, because without this graph, we cannot generate any path. So we'll pass the map, string, list, string, map. Okay? So if map get the word equal to none, we will not find any path, so we just return. Otherwise, for every next word in the map, get word, what should we do? We add the next to the list, and we do the backtracking. We keep choosing next word. So that will be next and the word map. Then we unchoose it. So list remove this list size -1. Yeah. Okay. So let's do the optimization. We can use the end set, because we can switch these two sets at some point, and then we add the end set at this end word. What we do only need to change the breadth first search part, so there will be end set, and the first is not reversed, so it's false. Okay, so now there will be set string, end set. Okay, the boolean is false, means that doesn't reverse. Okay. So if once the start set dot size greater than end set size, we reverse. So we will do the end set, start set, map, dict, and the reverse. We will get it to reverse. Then we return. Okay. Finish false. So what we do need to change is here. Once the end set contains the end word, contains the current word, and set contains the word, we find the way, so we finish. Also, other than the SW, we need to reverse. If if reverse is true, that means the original transformed word will be the key, right? So if reverse true, there will be word transformed word. otherwise it's S. And the value, if reverse is true, it will be S, otherwise it's word. So it's not S, it's key. So that will be key. Oh, sorry, key. Add the vowel. Okay. So if not finished, this will be temporary set and end set, and the map dictator. And we keep the same, the reverse. Okay. Okay, thank you for watching. See you next time.